Now we're going to spend a few minutes talking about what are called piecewise defined functions. And we know what it means to be a function. A function is a relation where for every x that goes in, there's only one y that comes out. Okay? And so we need to keep that in mind through all of this video and anytime we're dealing with a piecewise defined function. A piecewise defined function means that my function might be represented in different ways, depending on what value of x we input. So again, remember, and I will say it over and over and over and over again, but for a relation to actually be a function, that means for every x that goes in, only one y value gets to come out. So if I'm asked to find things like f of 3, or f of -2, or f of 1/2, or f of 0, for each of those x's that go in, there can only be one y that comes out. Now over here is our legend, okay, that tells us which piece that we're using each time. So if I want to find f of 3, x is equal to 3. And so then I come down here to my legend and say, well, 3 is greater than or equal to 0. And so if 3 is greater than or equal to 0, I'm going to plug it in to this expression here. Okay, f of 3 is equal to -1. It is only equal to -1. It is only represented by whatever comes out of this expression. That's my only option and possibility there. If I want to find f of -2, I come up here to my options and say, well, -2 is less than 0. And so if -2 is less than 0, I need to plug it into this expression right here instead. -2 plus 5. I do the arithmetic and say f of -2 is equal to +3. If I'm trying to find f of 1/2, I think about 1/2 and say, well, 1/2 is greater than 0. And so I plug it in to this expression and only that expression. -1/2 plus 2 is 1/2 or 3/2. Okay, so when 1/2 goes into my function, 3/2 is what comes out. Last but not least, if I want to find f of 0, okay, then I come up here and say, well, 0 is the place where I hop from one expression to the other, but this is the one that includes 0. Okay, so this is the one that I'm going to use. The opposite of 0 is 0, and 0 plus 2 is 2. f of 0 is equal to 2. When you're evaluating a piecewise defined function, for every x that you have, just like with any other function that we deal with, there's only one y that can come out. Okay, over here, this determines which expression we use to find that y. And it's only one of them. We only put it in one place or the other. Now, if I want to draw a picture of a piecewise defined function, I can't do 2 pages here, then let me copy and paste. If I want to draw a graph of this function, off my graph, then I'm going to draw the graph of each of these expressions. Okay, so if I want to draw the graph y equals x plus 5, I know it goes through the point 0, 5. I know I have a slope of 1, so up 1 over 1. Okay. And I can connect the dots and pretend that that's straight. However, if we look right here, we say I'm actually only going to graph that line for negative values of x. which means I'm not going to draw any of the graph on this side of the axis. I'm going to make that straighter. I'm only going to draw it in the other direction. 2, 3, 4, 5. So it's going to go that way and not have any part of the graph over here. Okay, I'll show you what to do here at 0 here in a minute. If I want to graph y equals negative x plus 2, then that has a y-intercept of 2, a slope of negative 1, and it says I'm only, however, while that line in itself goes like this, okay, it says I'm only going to draw it for values greater than or equal to 0. So it goes that way. Now, if I'm just looking at a graph like this, I understand that some students will try to stop it down here and say, well, I can't plug in 0, so they stop at negative 1. Okay. And that's not the case. It goes clear up here. I can use negative 0.1 and negative 0.01 and negative 0.001. But the 0.05 is not actually a point on my graph. So what I have to do is I have to cheat, and I have to plug the 0 in here just to see where I would be, okay, if I could be on that graph, or on this expression, on that line. And so I'm going to leave an open circle there at 0, 5. Okay, it's not actually a point on my graph, but I'm going to leave an open circle there to indicate that the line comes right up to that point. Okay, when x equals 0, I actually get to plug it in down to this expression like we did on the other page. Okay, so I'm going to make a solid point there. Okay. The important thing is to keep in mind that whatever I draw has to pass the vertical line test. This is a function, and so right here, I can't have 2 circles filled in because then it wouldn't pass the vertical line test. Okay. If there is a hop or a skip in your piecewise defined function like there is here, there's a break. One of them will have an open circle, and one of them will be filled in. Okay. There are piecewise defined functions that maybe touch each other. They don't have a break or a skip in them, okay, and that's fine. But if there is a jump between this expression and that expression, one of them will have an open circle, the one where the 0 is not included. The other one will be filled in. Okay, come see me if you have questions about this after you look in the book and play with them for a little bit.